Hey everybody, so today we're going to be taking a look at how marginal revenue interacts with the demand curve in order to tell us what's going on with elasticity. So for this, the key thing to remember is the total revenue test. And the total revenue test, if you recall, tells us that if price and total revenue move in the same direction, so if they both increase or if they both decrease, then that means you are inelastic. If they move in opposite directions, so if price increases while total revenue decreases, or if price decreases when total revenue increases, then that is an elastic portion of the demand curve. And if the price change yields no change in the total revenue, then that is unit elastic. So it's important that you keep those relationships in mind. If we do that and think of our demand curve and the concept of marginal revenue. Now, the concept of marginal revenue is the idea of the additional revenue that you gain from selling another product. So if you sell one good at $3, your marginal revenue is 3. And that means your total revenue is equal to 3. Because the total revenue is just the addition of all of the previous marginal revenues. So if at a quantity of 2, you have to lower the price to $2 in order to sell that second good, your marginal revenue, the additional revenue you get in from selling that second one, which is 2. Now your total revenue, in this case, is going to be 3 plus 2, or 5. Your third, you might have to lower it another dollar, making your marginal revenue 1, and your total revenue now 6. So that's how you have to think of it. Now, if you're looking at that along the demand curve, that means that in order to sell another unit of a good, your marginal revenue has to be lower and lower and lower. So that means it starts on the demand curve at the upper left-hand portion and then separates out, eventually going negative, going below the x-axis. Now, if we move a second to look at total revenue, which you can imagine the y-axis being sort of a total revenue measurement and the x-axis still being quantity, this means that your total revenue should be upward sloping until it gets to the point where total revenue, or where marginal revenue equals 0. And that's because your marginal revenue adds together. That means your total revenue needs to be increasing at a decreasing rate. Since your marginal revenue is positive, it's increasing total revenue the entire time. However, it's doing it by less and less and less until it flatlines right here. And that flat line is going to be at the same quantity where marginal revenue equals 0, because that means that you're no longer adding to your total revenue. Then once your marginal revenue goes negative, then your total revenue needs to start decreasing. So that's this downward sloping portion. So if we break up the total revenue curve into its 3 respective parts, the upward sloping part, the flat part, and the downward sloping part, we can now apply our ideas of the total revenue test to this concept. So remember, if price and total revenue move in the same direction, that's inelastic. Sorry. If they move in the opposing directions, so if price increases and total revenue decreases, or if price decreases while total revenue increases, that is elastic. Now, if we think of these two graphs as the same product, as we increase our quantity, we have to decrease our price. So when we're decreasing our price, this is what's happening to our total revenue. So we're decreasing the price and the total revenue is increasing up until the point where flatlines, where marginal revenue equals 0. That means we're lowering our price and our total revenue is increasing. That's this. That means we are elastic on this part in our total revenue curve. Where it flatlines and total revenue doesn't change with the price change, that is unit. And where a price decrease decreases total revenue, that's this. That means we are inelastic. If we apply that knowledge over to the demand curve, we use our marginal revenue as our dividing line where that hits the x-axis, because that corresponds to this area where it's unit elastic. So all quantities to the left of that need to be elastic. So this whole part of the demand curve is elastic. Then we have unit elastic where marginal revenue is equal to 0, and inelastic for every quantity to the right of that. So this part is inelastic. So this is yet another way of looking at the demand curve and determining where along it is elastic versus inelastic if you are given marginal revenue and you're not given any numbers. You can always find it by whatever quantity marginal revenue is 0. That is the same quantity on the demand curve where you're unit elastic. Everything to the left of it is elastic. Everything to the right of it is inelastic.